Dear students, today we will see some solved examples of ST paper. So these are the workout examples with illustrations. See carefully and understand the concept, how we can solve this buffer solution concept. So this is example of acidic buffer. So suppose it is required to make a buffer solution of pH is 4. So buffer solution pH is 4. Using acetic acid and sodium acetate. So these are the two mixtures. Now how much of sodium acetate is to be added? The concentration amount of this is added to 1 liter of 0.1 normative acetic acid, and K of acetic acid is given. So it is clear that this is the formula of Henderson equations. So acetic acid is given, pK is given, and they are asking the salt pH is also given. So we can directly put the value 4, and this is the value of Ka. So on solving, so we will get the concentration of sodium acetate, that is the 0.08. This is the concentration, so we will get molarity. So amount will be multiplied by the molar mass, you will get this answer. So this is the molar mass of the sodium acetate. Which of the following mixture is called as the buffer solution? So we have options like A, B, C and D. So see here, a strong acid, strong base. So this buffer cannot be possible. Buffer is possible only when the acid or base should be weak acid, strong base. So second is acetic acid, strong base. So in case of strong base, this can form a salt of sodium acetate. So this can form a buffer. Ammonium hydroxide and HCl. So both are. So this cannot be buffer. This can form a buffer. So in ammonium hydroxide and HCl, this is strong acid, and this is the weak base. So again they will form a salt, so it will undergo salt hydrolysis, that is the ammonium chloride plus water. So ammonium hydroxide will undergo, ammonium chloride will react with the water to form again acid and base. So this cannot form a buffer. But if you take this ammonium hydroxide and HCl, so what will happen here? The concentration is equal 500 ml here, but here concentration of this is lesser, this is more. So when the concentration of weak base is more than the HCl, there can form a buffer. So answer is your B and C can form a buffer, but A and C cannot form a buffer. A solution of weak acid was titrated with a base sodium hydroxide, and the equivalence point was reached when 36.12 ml of 0.1 molar sodium hydroxide have been added. Now this much concentration of HCl added to this titrated solution. The already solution is titrated, and if you add HCl to this solution, so definitely the pH is found to be 4.92, means solution become acidic. So what is the key of the weak acid? So key of weak acid we have to find out. So on being titration, what will happen? The milliequivalent of the weak acid will be equal to milliequivalent of the sodium hydroxide. So we know this milliequivalent, so same will be the milliequivalent of 3.612, the milliequivalent of the weak acid. Now this weak acid is again is reacting with the sodium hydroxide, so it will give you a salt plus water. Okay. So this is the milliequivalent at T equal to 0. This is there, and after the reaction, this will become this much. So this is your only salt plus water. Now this salt plus water will react. So this is a salt of weak acid it can react with the HCl because it's a strong base, salt of the strong base. So after addition of HCl, that is this much milliequivalent, that is the 118.06 millimeter. This is added, so it will form NaCl plus HA. So again it will form weak acid. So concentration of salt is more, concentration of the weak acid, strong acid is less, so it can form a buffer. See here, concentration of salt is more, concentration of the strong acid is less, then they can form a buffer. So whenever the concentration of salt is more than the concentration of strong base, they can form a buffer. So you can see the concentration of salt is after reacting, this is 1.8, here also 1.8, NaCl is 1.8. So these two will form a buffer, HA and sodium, they form a buffer. So we can apply this Henderson equation. So pH is equal to log K plus log salt by acid, and substituting value. So pH of the solution 4.92, K we need to find out, so log for this value. So this will give you K equal to 1.2 × 10⁻⁵. So this is the maximum buffer, that is the buffer capacity of the solution. How many mole of HCl will be required to prepare 1 liter of a buffer solution containing NaCl and HCl of pH 8.5 using 0.01 gram formula weight of sodium cyanide? So here 0.01 gram formula weight is given. We can convert to moles also, and weak acid dissociation constant is also given. Now in this case, NaCN HCl is a conditional buffer. Why conditional? Because concentration of buffer is there. HCl is a weak acid and this is the salt of the weak acid. So again, concentration of HCl is less than the concentration of sodium hydroxide. This we have to keep remember. So when NaCN is reacting with the HCl, this will give you NaCl plus HCN. So initially the concentration of HCl, let us take X. This is given here. How much? So 0.01 mole. Formula weight is given 0.01 mole. So on reacting with HCl, so this will give you what? HCl will fully consume. HCl will be fully consumed. So it becomes XX. This will be 0.01 minus X. So take the formula of Henderson equation. So log pH is equal to pH is given at 8.5. K is also given, salt by acid. So salt is nothing but the 0.01 minus X divided by X. So you will get the answer. X is 8.85 into this. So this is the moles of HCl. This is the moles of HCl. So one more important questions which are often been asked in the competitions. The pH of the blood stream is maintained by a proper balance of H2SiO3 sodium bicarbonate concentration. So this is two substances present in our blood stream. So they will make the blood our buffer, and in this condition our blood blood becomes so many biochemical reactions possible in these situations. So due to this buffer concentration, many biochemical reactions will easily take place in the blood stream. Now, what volume of 5 molar sodium bicarbonate solutions should be mixed with 10 ml sample of a blood, which is 2 molarity in H2CO3 in order to maintain a pH of 7.4. Now, pH is given here, what? 7.4. And we have to mix 5 molar of sodium bicarbonate solution. The concentration they are asking volume, molarity they have given it. Should be the 10 ml sample of the blood. So you have taken a sample of blood is 10. So which is 2 molarity. So H2SO4 is 2 molarity. So we are not changing the H2SO4 but only changing the salt concentration. So concentration of H2SO4 given here. Here K is also given. K for H2SO4 is given. So concentration of acid is given here 2 into 10 by V plus 10. Why 2 into 10? Because 2 molarity. Volume is 10. 10 is the sample of blood. 2 into 10. This is the and VML is the sodium bicarbonate. This is the volume of sodium bicarbonate used. You have to add with the H2SO4 also because volume is increased. Similarly, concentration of SiO3 is on increasing the volume. This will automatically decrease. So V into 5 into V. So 5 molarity is given. V they are asking 5 into V. V plus 10. So concentration of acid we all know that. Concentration of salt we also know that. Now substitute the value. Salt by acid. K we know that. pH we know that. So on solving, so you will get answer 78.36. Two buffers X and Y. There is two buffers X and Y whose pH is 4 and 6. So this is the two buffer X and Y. pH is 4, pH is 6. So here we have to write 6. So write 6. They are prepared from acid H and salt of Na. So this is the acid, salt of Na. Acid, salt. This acid is 0.5 molarity. This acid 0.5. Now if you mix it, on mixing volume will be double. This and this volume will be double. So both buffers are 0.5 molarity in HA. So this 0.5 HA. On doubling, what is the pH of this solution? And K of HA is given. So now on mixing, molarity of sodium Na is also changing. Concentration of NH is also changing. So we have to find new concentration, and K will remain same. So what is the new concentration? Let us see that. We will use the equation, normal equation, M1V1 plus M2V2 into M3 into V1 plus V2. So for buffer X, so pH is equal to this much. So here we will get the concentration of salt is 0.05 molarity because concentration of acid is 0.5. This is same. This is pH 4. Similarly for Y, pH is 6. So here we will get the concentration of salt is this much. On solving, so we will get two concentration. So for this concentration, V will be same. So on mixing, when you mix together, what will happen? So concentration of this will change and this will also change. So for salt, M1 V1 plus M2 V2, so M1 is 0.05. We have seen it. Let me show you once again. This is the 0.05 molarity. This is the 0.5 molarity. So for salt, 0.05 molarity into V plus 5 molarity into V equal to M into 2V. So we will get the concentration of salt. Similarly, we will get the concentration of acid. 0.5 into V plus 0.5 into this is given, already this is given here, so we'll get here 0.5 molarity. Now we can find the pH. pH will be Ka given, so salt is this side, acid this side, solve it, you will get the pH. H plus in 0.2 molarity solution of formic acid. So formic acid solution 0.2 molarity and concentration H plus is given 6.4 into 10 per minus 3 moles per liter. And to this solution formate is added, means we are adding some salt to adjust the concentration of formate to 1 molarity. So in this case, if you add this one, the concentration of formate becomes 1 molarity. What is the pH of this solution? And again they have given alpha for sodium acetate is this much and alpha for acetic acid is this much. So from here, what is the concentration of formic acid in this solution? So concentration of formic acid will be given this much. So this is nothing but a C into alpha. If you solve this one SCOH, so it will give you, as per the equilibrium, to undergo react with the water, it will form HCOO minus plus H plus. So this is nothing but a C into alpha. So C into alpha, so alpha we don't know, so 0.2 into alpha, and the concentration H plus is given 6.4, so we will get here alpha value. So now when you add the sodium formate, so on adding sodium formate, what will happen? This will be suppressed and the new alpha will be decreased. So this alpha is greater, this will decrease due to small dissociation. So what will happen? Formic acid, concentration of formic acid before and after dissociation will be taken same practically. If you take the same almost, means like this much concentration, so this is take same, this will be again 0.2 molarity, okay, because of small dissociation of the this one be a small value of the new alpha, so dissociation will be almost same, concentration will almost same. So this concentration given 1 molarity, concentration of the formic acid is 0.2 molarity. Now concentration of the sodium formate is this one, so this will undergo into this and this plus. So initially it is 1 molarity, then after dissociation what will happen? 1 minus 0.75 and alpha is given here, this will alpha, okay. So you will get the concentration of formate is 0.075, this is the 0.075. So we got the salt and we got the formic acid. So now using Henderson equation, we got the salt is 0.75, acid is 0.2, K is given. On solving, you will get the pH equal to 4.19. So this is the pH of the solution on addition of the formate ion. Calculate the pH of the acidic buffer mixture containing 0.1 molarity of weak acid and 0.1 molarity of sodium acid. So this is given here, this is the salt, and again weak acid given here 0.1 molarity. So now this is Ha, so it will dissociate into H plus and A minus. So this is the 0.1 molarity. So what is the concentration of H plus? H plus will be this, and what will be A minus? So A is also given by the acid also, and A is also given by the sodium acid. Already 0.1 is given, so this will be 0.1 plus X. This will be 0.1 minus X. So K will be, solving this one, take the law of chemical equilibrium or mass action. So on law of mass action, on solving this will, so you will get the X equal to 0.05. So now what is the concentration of A? Is nothing but the 0.1 plus 0.05. So A is the concentration of A is this much, 0.1 plus X we know the value 0.05, so this will be 0.015. So concentration of HA will be 0.1 minus 0.05, this will becomes 0.05. Now we can find the pH. So pH equal to pK plus log of salt by acid. So salt is given here 0.0. No, this is the acid is given and this is salt is given. This is salt, this is the acid. So we can put this value. K is given here 1.5 into 10 power minus 1. So on solving you will get answer. So pH is equal to 1.2. This is our answer.